Everyone loves Supabase. It is an incredible open source platform that definitely seems to be the most popular database for AI agents right now. It's Postgres SQL under the hood, so not only can you use it to manage the conversation history and state for your agents, but you can also use the PGVector extension to literally turn it into a vector database for RAG. So it's just the perfect platform for AI agents, not to mention all the other awesome features as well, like authentication and object storage that you get right out of the box. And so to me, it definitely seems like no matter what you are building with AI, there is a place for Supabase. Because Supabase is so incredibly useful and powerful, it was no surprise to me that many of you asked me to include it in the local AI package that I've been working on and that I've been sharing some on my channel. And luckily, since Supabase is entirely open source and they have instructions for self-hosting it with Docker, it's actually pretty easy for us to bring it into the fold of our local AI services, and that's exactly what I'm going to show you how to do in this video. Now, Supabase was a little bit trickier than the other platforms to get incorporated, but that's why I'm going to walk you through it step by step right now so that you can get this revamped local AI package up and running super quickly. And the best part is, if you've used Supabase not locally before, everything is going to look very familiar to you. I'll even show you how to build a RAG AI agent in N8N that's running 100% local using our Supabase instance. Plus, we'll use a local file trigger instead of Google Drive like I've done with other videos on my channel, so that it actually is entirely local. I know that's a big thing that a lot of you ask for in other videos on my channel with this package. Also, I just want to say that this local AI package revamp that I'm doing now is just the beginning. I really want to turn this into the golden standard for local AI and also start to incorporate it into other projects that I'm building like Archon. So more on that later. You know I'm always the guy with big ideas. And so with that, let's dive into setting up Supabase locally. So this is the local AI package completely revamped now with Supabase. And it has its own dedicated GitHub repository now. So before, I just had it with a bunch of other things in my AI agents masterclass GitHub repo, but now since I'm revamping it and doing a lot more with it, I have a dedicated place for it. So I'm going to have that in a link in the description of this video. Check it out right here. This is the README that you'll see at the homepage of the GitHub repo. And this local AI package was originally made by the N8N team. Let me zoom in a little bit here so you can see this. So I took what they built and they curated together, and I built on top of it in previous videos on my channel to add things into the package. So it started out with just N8N, Ollama, Qdrant, and Postgres. Those were the 4 services in the local AI package. And then I added in Flowise for another low-code AI agent builder, Open WebUI so we can have a ChatGPT-like interface. And now I'm adding in Supabase, which I'm replacing Postgres entirely since Supabase is Postgres under the hood. And then Qdrant is also kind of similar because you can use it as a vector store just like you can use Supabase, but I'm keeping Qdrant in there. I kind of have a note on this here just because it's faster than Supabase. So for some use cases, you might actually want Qdrant, but in general, I love using Supabase just because I can use it as a SQL database and as a vector store for RAG as well. So this is everything that is now in the local AI package. I'm going to show you how to get it all set up right now. All right, as I walk you through this guide step by step for installing the revamped local AI package, I'm going to be sure to hit on some points that I missed in other videos on my channel for this package. Things like how do you actually restart and update your local AI stack, or how do you exclude things like Ollama if you're already running it on your computer so you don't want it running in Docker as well. So even if you've seen other guides on my channel for this local AI starter kit, this is still going to be really helpful for you. And then if you haven't, I'm still going to be very comprehensive going through this step by step. So back to the README here, which again, I'll have linked in the description of this video. It's just the homepage of the GitHub repository. Scroll down until you get to the prerequisites section because I want to focus on this first. There are a few things that you have to have installed before you can go on to the rest of the installation instructions. The first thing is you'll need Python here to run a script that does a lot of the Supabase setup that I'll show you in a little bit here. And you'll also want Git or GitHub Desktop to obviously clone this repository. I'd recommend GitHub Desktop if it's on your personal machine, not on some computer in the cloud if you're hosting local AI there. And then also Docker or Docker Desktop, because all of these local AI services run as Docker containers. And I'd recommend Docker Desktop, again, just like with Git, if you're running this on your personal computer. And so once you have all these prerequisites installed, just using these links right here, you're good to move on to the rest of the installation instructions, which I'll walk you through step by step right now. So the first thing you're going to want to do is clone this GitHub repository. So you just take this first command right here, open up a terminal and go ahead and run it. And obviously I already have this repo cloned, but if you don't, then it's going to pull all of that from GitHub. You'll get a very different output right here running the command. And then you go ahead and change your directory into local AI package. So now my current directory in my terminal is exactly what I have open up here in my IDE. And it's a pretty simple repository overall, because it's not like we have to have the code for all the different services bundled into this repository. We just have to reference the Docker containers in our primary file right here, which is our docker compose.yaml. So this file is responsible for defining all of the different Docker containers that we want to pull together and create for our local AI package. And so everything that you saw in the README right here, we have defined in this Docker compose file. So we've got N8N, Ollama, Flowise, WebUI, all these are defined as the individual containers. Like this is the WebUI block to say that we want that as one of the services within our stack. And these are the configuration items for it, like the port that we're hosting it on and the name of our container that we're going to be using in our Docker Compose network. And the one thing that is not included in here is Supabase. So I'm going to touch on that in a little bit here, because we actually need to clone the Supabase repository separately and use a separate Docker Compose file combined with this one. And the primary reason is actually because Supabase runs many different containers together when you host it locally. And so it's kind of a mess if I just dump it all in this Docker Compose file. So more on that later. But let's actually get to the next part of the setup, and then we'll dive into some of the intricacies of getting Supabase specifically installed into this package. So yeah, after you have everything cloned and you've changed your directory, now it's time within an IDE to make your .env file and to set your environment variables. And it's pretty simple overall. There's going to be a lot of environment variables that you see in the .env.example file. I'll open that up right here. There is a ton here, and this mostly comes from Supabase because there are so many different things in Supabase that you can configure. It looks pretty overwhelming. But luckily, to get just the foundation of Supabase set up, you can leave most of these environment variables as their default values. There are only a few that you actually have to care about that I have pointed out in the README here. So that is what we're going to set up right now. If you want to do more complicated things in Supabase, like set up their email authentication, there are more environment variables and more setup for that, but you don't need that for most of the AI use cases you'll be building with local AI. So we'll not cover that right now because I want to keep that concise, but just know that there are a lot of other things if you want to set up other stuff in Supabase. And they have a guide for that as well. So I'll have this linked in the description of the video as well, because Supabase put out a very comprehensive guide for self-hosting with Docker. And this is actually the resource I used to learn how to incorporate Supabase in the local AI package. So a lot of the stuff that I'll show you how to do in a little bit is actually going to be using this. So use this as a guide, both in this video and also more of the advanced stuff at the bottom if you want to learn other things like dashboard authentication, or actually setting up more advanced things like your email server if you want to configure an email server within local Supabase. Not the stuff I'm going to cover right here. So anyway, all we're going to do right here, I'm going to actually delete this .env file and start from scratch. I'm going to make a brand new .env file, walk through setting up all of the configuration with you right now, and we're going to do it pretty quickly. So don't worry, I'll walk you through it step by step. It's not actually that complicated here. So I'm going to copy everything from .env.example and then paste it into this new .env file that I just created here. And so the first thing at the top is our N8N credentials. And these we can actually set to whatever we want. So we define the secret here. And this can just be a random alphanumeric string. Doesn't really matter what you set here. I don't care either what I show you right here, just because this is running entirely locally on my computer, and I'm going to reset my .env after I record this video anyway. So that's everything for the N8N. You just define your own JWT secret and encryption key. And then the rest of what we want to set up is for Supabase specifically. And so the first thing that we need is our Postgres password. So this is going to be the password for our database. And again, just like with N8N, you define this yourself. So I'm just going to do something kind of silly here. I'm just going to say test password, because again, I'll change this later. And then we want to set our dashboard login as well. So just like when you use a hosted version of Supabase, you can log in to see all your tables and your users and your SQL editor and all that. You have the exact same setup with local Supabase. And I'll show that later as well. You have your own locally hosted dashboard as well. And so this is the login for that. So that you can set the username to whatever you want. The password the same as well. I'll just say test dashboard password. I don't really care how secure it is right now. And then these two values you can leave as the default. And then we'll get to these three in a second here. The last thing that I'll show you how to set before we go back to the Supabase documentation is the pooler tenant ID. And so this is for the transaction pooler connections to your Supabase database. And so for this, it doesn't really matter what you set it to, just set it to some number right here that will be your tenant ID that you'll use again for when you are connecting to Supabase with the transaction pooler method. And so that is everything besides the JWT secret. So let's actually go back to the guide right here for self-hosting with Docker, because they have a really nice little tool here that actually helps us get set up with these last three environment variables we need to configure. So if you scroll down a little bit above the halfway point for the documentation, you'll see right here, it actually generates a JWT secret for you. So if I refresh the page, watch this. We have Y1RM. If I refresh the page and then come back, look at this. It changed. So we have a brand new JWT secret every time we refresh this page. So we can just use this for our secret. It's really convenient that we don't even have to bother generating it ourselves. We just paste this in right here, and that is our JWT secret. And then for the anonymous key and service role key, we can go back to the documentation and it can generate those for us. So you just click on anonymous key and then you click on generate JWT, and then boom, we can just copy this and bring it into our environment variable right here. So I'll just go ahead and replace what I have right here. Nice and easy. So these are the keys that are usually generated for you when you have the remote Supabase instance. But now since we're running it locally, we have to actually define these ourselves. That's what we're doing right now. And then for the service role key, we'll just click on this drop down, switch it to service key, and then click on generate JWT again. So I'll go ahead and copy that and then replace that service role key just like I did the anonymous key. And then look at that, boom, we now have everything configured for our environment variables. It was actually pretty easy overall. And so now we can finally go on to getting everything started with the Docker Compose stack. Now to spin up our local AI stack, there are a few different commands that we see here depending on your architecture. So if you have an NVIDIA GPU like me and you want to use that for your LLMs in the Ollama container, you'll use this command right here. And then if you have an AMD GPU on Linux, you can use this. And then for Mac users, you unfortunately can't use a graphics card within a Docker container. It's just a limitation of Mac. And so you can either just run entirely on the CPU, which you can still use smaller local LLMs like less than 8 billion parameters with just a CPU, or you can not run Ollama at all. So if you do -- profile none, it's actually just going to not run the Ollama container at all. So if you have Ollama running outside just on your computer, you can still reference that from within your N8N container or your Supabase container, whatever it might be. And then there's some additional instructions for using Mac as well. So that's everything depending on your architecture. Also, if you just aren't on Mac but don't have a GPU, you can run on the CPU as well. And so all of these commands together, each of them are using this startservices.py. And this is a script that I made for you to make it super easy to get everything up and running. And the reason it's a little bit more complicated now is because Supabase is not just a single container. Let me show you what I mean. It's kind of interesting. So if you go into the Supabase GitHub repository, which you'll see in a bit why I actually have this in source control right now, and then you go into the Docker folder and then go into the Docker Compose file, Supabase actually has its entire own stack, just like I have for my Docker Compose file for the local AI package. And the reason they have that is because Supabase is actually made up of many different containers combined together. Like you have the Studio, which is the interface you're used to seeing when you have a Supabase running remotely. You've got Kong, you've got the authentication container, you have the REST container, real-time, all the different services that you have, like the object storage in Supabase, are running as individual containers combined together. And so I can't really just copy this entire thing and then go into my own Docker Compose and just dump it all in here. I mean, that's going to be a total mess. And I don't want to have to manually update the container versions when Supabase updates things. So I want to actually be able to reference their Docker Compose in their GitHub repo and combine that with my own. And that is exactly what this Python script does for you. So it'll actually clone the Supabase repository or pull it to update it if you've already run this script before. And then it'll combine the Supabase Docker Compose file with our own for the local AI package to bring everything together. And this is a little bit more technical. So don't worry if you don't understand this part, but it's really important that we also run it on the same Docker network. So that way our N8N instance or whatever other container we have can very easily connect to our Supabase containers as well. And so this right here is the what I pass into the command to make it all run on the same Docker Compose network. So that's super important. And then another thing that the script does for you is if you ever want to restart everything, like maybe you want to shut down your stack for a bit and then turn it on later, or you want to update one of your environment variables and have that actually take effect, you can just run the script again. It is that easy, and it'll restart everything for you. And then another thing is if you want to upgrade your containers, like maybe there's an update to N8N or an update to Supabase, whatever it might be, you can just follow these commands in the README right here, and that will take care of everything. You just spin down everything with this first command, pull the latest updates to all of the containers in both stacks with this command, and then you just run the start services.py with your profile like CPU or GPU NVIDIA, and it'll rerun everything. It is that easy to restart things, to take new effects with environment variables, and to update your containers as well. So I hope that makes a lot of sense. And so right now, I'm just going to go ahead, since I have an NVIDIA GPU, I'm going to take that first command at the top, just copy that, go over to my terminal, and I'm going to go ahead and run this. And so for me, since I've already run this before, it's just going to pull the latest changes from the Supabase repository. It'll actually pull everything for the first time if you haven't run this before. And then it's going to tear down all of the existing containers that are running and then reboot them all back up. And that is how I do a full restart here. And also, really important to note, if you already have workflows in N8N or Flowise, or if you have data in your Supabase tables, tearing down the containers will not get rid of that. So you don't have to worry about losing anything when you run this script to restart your containers. Everything will persist. So do not worry about that. I know that's a big question that I had when I was first covering the local AI package on my channel here. And so right now it is, it's tore down everything, and now it's restarting all the Supabase stuff. And so it takes a little bit here. Well, actually, it's basically already almost done. You do get a warning right here where it says it found orphan containers for everything that was just started with Supabase. You can ignore this. I don't know exactly how to fix this. If you know, just let me know, and I'd love to take care of that. But anyway, yeah, everything is up and running now. So I can actually go to my Docker desktop here. Let me show this. By the way, these are the settings that you want for your Docker desktop. There's a couple of things like exposing the daemon without TLS that you may want to make sure that you have checked if you're using Docker desktop with Windows. Just a little tip there, a little aside. There's a troubleshooting section in the README as well that I would definitely check out if you're having any problems. But yeah, I'll close out of the settings here. I'll go to my local AI package right here running in Docker desktop. And look at this. We have all these different services running here. Which is super neat. There's so much that goes into this package now. You can literally like go into Ollama. I can look at the logs for it. I can go into the exec tab and I can actually enter in a command. Like I can say Ollama pull, and I can look, or Ollama list, that's the wrong command there. And I can see the models that I have available to me in Ollama. And I could even say Ollama run, and then I could copy the name of the LLM that I have pulled. I'll show in a second how I defined this. I'll copy this and paste it. And then boom, I'm now interacting with Qwen 2.5 instruct. And since I'm using the NVIDIA GPU profile, it is using my NVIDIA GPU to run Qwen 2.5 right here. So look at that, super neat. So you can interact with all these containers and see the logs as you are running things in your local AI package. And by the way, let me actually show this really quick here. In the Docker Compose file, this command right here defines the LLMs and embedding models that are pulled for Ollama by default. And then the very last thing that I want to hit on before we create an agent together is I have a troubleshooting section in the README right here with some common problems that I've seen with running Supabase locally and some things that I've actually run into myself. So hopefully if you run into any issue, it'll be listed here, and there's a resource for a lot of these. You'll be able to get through everything that I ran into if you did yourself. That's kind of the goal of this troubleshooting section here. So that is everything for getting the local AI package set up. You now have everything up and running. So like you can literally go to localhost port 6333 /dashboard, and then boom, there's Qdrant. I know we're not using that in this video right now, but I'm just showing like everything is available to you. You can go to let's see, 3001, and then boom, there is your Flowise. And you can go to 8000, And then you have your Supabase. And if you go into it for the first time, it'll ask you to input your username and password, which remember, you set as the dashboard username and password in the .env file. And this should look very familiar to you, everything that you're used to seeing when you go to the remote Supabase instance in your browser. And then we also have N8N. So you're going to go to localhost port 5678, and then it'll have you create a local N8N account. It's not actually a cloud one, so it is running locally. It'll have you create an account, and then you'll have this overview right here where you'll have the local RAG AI agent as that one workflow that is imported automatically. But we're going to actually create another one here. So I'm going to create the Supabase RAG AI agent. I'll have this automatically import into your N8N instance as well. So this will immediately be available to you when you go into N8N. The only thing that you actually have to set up yourself is your credentials. And so I'm going to walk through that right now and just briefly describe how this agent works exactly. And so first of all, it's just a basic AI agent using the agent node in N8N, where we have our Ollama chat model connected. We have Supabase for chat memory, just using the Postgres node. And then we have Supabase for our vector retrieval so that we have RAG through Supabase now instead of Qdrant. And to get all the credentials set up, I'll start with Ollama here. You'll go to credentials and the drop down here, create a new credential. And then the base URL is going to be Ollama instead of localhost. So it'll be HTTP Ollama, and then the port is 11434. And then when you click save, it'll automatically test your connection. And if the containers are set up and all running properly, it'll say connection tested successfully. I'm going to switch back to my other credentials here, and then it'll load all of the models that you had pulled with Ollama when it was first imported. And so we got our embedding model and then Qwen 2.57b instruct as well. And then for Supabase here, our connection through Postgres, I'll create new credentials. The host is actually going to be DB. And the reason it's like that, I'll actually go back over to my IDE here and then go to the Docker Compose file for Supabase. Look at this. The Supabase, the primary database container in the stack is just called DB. And since these containers like N8N and Supabase are all in the same Docker network, we can connect to it by just referencing the name of the container as the actual host. And so then our database is going to be Postgres, and then the username and password is going to be whatever you have set up in your environment variables, and then keep the port the same. All that is good to go. I'm just going to close out of this, but if I actually go and edit my other credentials that I have right here, and then you go ahead and click on, I'll just click on retry, you can see, just like with Ollama, connection tested successfully. So that is everything with Ollama and then Supabase. And then when you connect, let me just show this, there's a slightly different setup when you connect with the Supabase vector store versus actually connecting with the Postgres node. The host, this took a little bit of time for me to figure out. So I hope that I save you a headache with this. You can't actually say DB right here. For some reason, this doesn't work. If you say DB for the host name here, you have to actually say host.docker.internal. So essentially that's telling N8N to go outside to my machine, my local PC, and then go back into port 8000, which is mapped onto the Supabase container. And so then you just have your service role secret, which you have set in .env, and that is it. That is all the credentials that you have to set up. You can reuse those credentials for the rest of this workflow as well. This is the workflow that actually brings files that we put in a local folder into our local Supabase vector store. So let me really quickly show you my RAG pipeline right here, how I get local files into my local Supabase. And then we'll test out the RAG agent here. Just a really nice and simple demo. You could literally just do this kind of RAG setup within WebUI with the RAG functionality, but I just want to keep things simple here. You could definitely take this workflow and extend it to your heart's content in N8N. Again, this is going to be automatically imported into your N8N instance when you pull the repo and run everything like I showed you how to do earlier. And so at the start of our pipeline right here, as promised, it is a local file trigger. And so it's watching for files that are added and changed in this folder specifically. And the reason I know to use /data/shared is if I go to the Docker Compose stack and look at the N8N service specifically, the shared folder, which is this guy right here on the left-hand side, is mapped to /data/shared in my N8N container. And so when I add a file in here like test.txt, this file is now also in my container right here in /data/shared and then /test.txt. And so I'm using this folder so that I can dump things on my personal computer and have it actually go in my end-to-end container as well and trigger this right here. So you also want these two options ticked, by the way, otherwise this won't work. But I'll go ahead and click on test step, and then I can actually go back into here. And let me go back to my test file. I'll paste in some content right here that I just want to have in my vector database. So super simple test information right here. Click on save, and then boom, look at that. We now triggered with a change event, and then the path, which we're going to be using as our file ID essentially in the vector database, is set right here as well. So then I can go on to the next node right here, which is basically just determining if it is an add or change event. Because if it is a change event, like it is in this case, we want to clean the vector database of any vectors for this file specifically. So using this metadata filter, again, using the path as a file ID, we're just cleaning the vector database of anything with this file so that we have a blank slate to make sure what we are inserting is really everything for the updated file. We don't want any old vectors hanging around for a previous version of the file. And then we pull the file within our end-to-end workflow. So now this node right here gives us this data output, which is the contents of the file. Actually, it really is the file itself. And then in the next node, we extract the text from the file. And so at this point, we put a file on our local computer. It went onto our end-to-end container into our workflow, and now we have the text from it. It is nice and simple. And then the next thing that we want to do within our Supabase node, before we actually run this, we need to set things up in our database here. So if you click on the Docs tab right here, it'll bring you to this page. Scroll down a little bit and then click on a quick start for setting up your vector store. You want to copy all of this SQL right here because this is how we are going to set up our vector database here. And so I'm going to go to SQL editor, and then I'm going to click on the plus icon, create new snippet, and then paste this in. Boom, there we go. And now we can run this right away, except there's one change we have to do. The size of our vectors is actually 768 because we're using the nomic embed text model from Ollama. That's just the vector size specifically. So we'll change it to that. This you can set to whatever embedding model you're using, what the vector size is. And then you can go ahead and just run this by clicking on run in the bottom right. And fails for me because I already have executed this, but for you it'll work. And then we'll have this documents table. Let me scroll down to that right. Where is the documents table? Right here. Boom, there we go. So it's an empty documents table right now. But what we can actually do is we can run this to insert our vectors. And usually I get an error like this. It's kind of weird. There's not actually a problem with my workflow. All I have to do is just save and then refresh. So I'll refresh N8N, and then I'll just run test step right from the Supabase vector store. I'll make a change to my file just to trigger things again, and then it executes, and boom, there we go. So it's a little glitch with N8N where when you are going through it step by step, it fails at this node for some reason. But anyway, I refreshed and ran it right from there. And now if I refresh in Supabase, we have our record here. So my to-do list is, and then look at that, it looks really, really nice. And we got the file ID for the metadata. Everything is looking good. So now what we can do is go into our chat, and it's kind of a weird file, so I have to be explicit here telling it to use RAG, but I can just say, look at my test file and tell me what my to-do list is. So now I'm chatting with Qwen 2.57me instruct running locally using my GPU. And you can see here that it invoked the Supabase vector store tool, retrieved my to-do list. We can even see the results of that right here from what it pulled from the vector store. And look at that. Based on your test file, your to-do list is watch a movie, code the next big SaaS, and learn how to tie my shoes. All right, it is working perfectly. Again, just a very basic demo example here, but we have everything, including Supabase, running entirely locally, and you could go and deploy this to the cloud, keep it on your machine, do anything that you want with this, extend it with more services. The world is your oyster with this local AI package. So there you have it. We now have Supabase running entirely locally in our local AI package, which really is starting to shape up to be the perfect tool for you to run all your AI locally and build any AI agent that you could dream of. And I have a lot of plans, like I already mentioned, to keep expanding this local AI package. But also, I want to hear from you. So let me know in the comments what other tools or services or frameworks you think I should include, because I really want to build this into the golden standard for local AI, but I need your help to make sure I'm including everything that I should. And really, this is a community-driven project as well. So, if you appreciated this content and you're looking forward to more things local AI, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.